I'm a modern apps solution engineer at VMware Tanzu. In this session, we are going to give an overview of the principal challenges for securing your software supply chains, and an introduction to how cloud-native Buildpacks can help keep your supply chain up to date and secure. You probably know that every organization nowadays is trying to innovate faster and delivering more value at greater speed. So deployment frequency, adaptability, and velocity are the focus of modern software development teams to help their organization stay competitive in an ever-changing market. But meanwhile, it's a fact that software supply chain attacks are increasing in severity and frequency year on year. Okay, sorry. These increased security concerns cause velocity and agility reduction. That is the opposite of what business wants. But what is a software supply chain? Well, a supply chain is a process of delivering a product to the customer. But in the software domain, this process is loosely defined. And while software supply chains grow increasingly complex, consensus or agreement on best practices and security has been lacking. So the bottom line here is, on the one hand, an industry that is maybe too obsessed with the velocity and speed of deployment that leads to a lack of strong defaults and security best practices. And on the other hand, an increase in attacks would require the industry to go on the opposite direction. Software supply chain attacks occur when the materials or processes of producing software are themselves compromised. And supply chains require multiple linked processes, and its security relies on validating and verifying each of these processes. That's something to think about each time you have to integrate new components in the application. This is, well, let's think about the automotive industry, where the car safety is directly proportional to the use of certified parts. So what if mechanics or engineers were allowed to use openly available parts? There could be no guarantee about safety or standards. But also, adding new component in the pipeline itself could be dangerous. There have been numerous cases where malicious artifacts have been inserted along the delivery pipeline. And that's why the CNCF, the Cloud Native Computing Foundation, through the Cloud Native Computing Foundation Software Supply Chain Best Practice paper, identifies 4 key principles to follow to mitigate these kind of risks. These principles are verification, automation, authorization, and authentication. And these key principles are to be applied to the 5 stages of securization for the supply chain. These are securing the source code, that is, securing code produced by the internal or by the first-party software developers. Securing the materials, that is, hardening the raw materials of second and third-party developers, and so all the dependencies and the shared libraries. Securing the build pipeline, so securing the build and the infrastructure. the artifacts. And finally, securing the deployments, that is, verifying the attestations during the deployment stage. Each of the stages should be designed to complement one another for a comprehensive and holistic approach that is key for security. But let's delve into one of these stages, for example, securing the materials, to understand how it should work. Well, we know that in manufacturing, any process's overall quality and consistency largely depend on the quality of the materials of the goods used as inputs. Therefore, care must be taken to validate the quality of these raw materials. For software pipelines, what does it mean? Well, it is related to the dependent library's quality. A key part of the software factory process, in fact, is to ensure dependencies are drawn from a trusted source and have been tampered with. Well, not knowing where all your software comes from means having hard to spot risk. And dependency can open the door to breaches, exploit, or attacks to the supply chain. So to achieve these results, the CNCF recommends, between other recommendations, requiring an SBOM from third-party supplier and generating an immutable SBOM of the code. And what is this SBOM? It's a software bill of materials. That is an inventory, a list of ingredients that make up software components. Generating an SBOM creates like a snapshot of the components of your container at a specific time during your development process. And by generating an SBOM for each build and at each stage of the development, you can look for differences over time. Some of these differences might be expected, but any changes must be investigated to determine if they introduce new risks. So we can say that SBOM are indeed essential for supply chain risk management. But a study from 2021 stated that only 25% of the respondents produce an SBOM for the containerized apps they built. That's a very low number. And why? Well, another study discovered that over half of developers feel security policies stifle their innovation. So our purpose should be to make security so simplified and accessible that development teams don't even realize it's there, so that security becomes a business enabler and not a business reduction, a business limitation. But how can cloud-native Buildpacks help us achieve these results? What is a cloud-native Buildpacks? Well, cloud-native Buildpacks is a project to transform the source code of the most popular languages into OCI-compliant containers. This project started in 2011 by Heroku, and then Cloud Foundry adopted it 2 years later for the enterprise customer segment. These two companies had a very different user base because Cloud Foundry clients were some of the largest customers globally, whereas Heroku was more focused on small startups and mid-market company. Interestingly, developers and operators from both these companies really appreciated the Buildpacks, this technology. And that's why later in 2018, Heroku and Pivotal teamed up to start a new project, Cloud Native Buildpacks, as a CNCF sandbox project to try to standardize this technology. And currently, Cloud Native Buildpacks are an incubating project in the CNCF. VMware is one of the main contributors for this project, but it's not the only one. Indeed, there is a broad industry-wide adoption. For example, Google Scaffold use it, HashiCorp, Google Cloud, Salesforce, DigitalOcean, all use Cloud Native Buildpacks. Well, why? What are the real advantages? Well, Cloud Native Buildpacks can offer images that can be built directly from the source code without further instruction, because there is an automatic recognition of the language and dependencies. You can get instant base images updates without having to rebuild everything every time. There is an advanced cache that allows you to improve the performance of the various operations. And you can access SBOM files in various formats. This specification, the Cloud Native Buildpack specification, adds value in two portions of the container life cycles. That is the creation and the maintenance. Because by introducing a layered model, distinct layers in the architecture, and employing the use of container registry, Cloud Native Buildpacks make maintenance hassle-free. And now we'll see some details about it. So at scale, thousands of images can be updated in a matter of seconds when built using the Cloud Native specifications. And in addition to these advantages, the Cloud Native Buildpacks spec require the generation of metadata related to the internal build and to the export process that we'll delve into in a few minutes. This metadata helps determine what each layer within the container image is composed of, and the components and dependencies of the application. So what are the building blocks of Cloud Native Buildpacks? Platforms, lifecycle, Buildpacks, and stacks. Let's start from the platform. Well, a platform, it's a tool that makes Buildpack functionality available to the end users. We interact with a platform to use a Buildpack. Well, the platform is generally used as a CLI tool, but also can be a cloud platform component or part of a build pipelines. The main platform for cloud-native Buildpacks are Pack, that is the standard platform. Keypack, that is an implementation for Kubernetes led by VMware. Spring Boot, that has Buildpacks included, and so on. Then we have the life cycle. So from the platform, we interact with the life cycle. The life cycle orchestrates the Buildpacks and produce the final image through a series of steps. These steps starts from starts from the detection step, where groups of Buildpacks are tested against source in order, and first match is selected. Then we have restore, that is the step that restores layer from the cache. Then the analysis, where metadata created from previous builds are retrieved. Then the step of builds that transform the source code to a runnable image. And then finally, the export and the cache. Export creates the final OCI image, and then the cache combines information from the analyze phase to ensure only change layer are to be updated. That is one of the main points. Then Buildpacks. Well, what are these Buildpacks? Well, a Buildpack is a way of adding arbitrary content and behavior into an image while ensuring it's manageable, auditable, repeatable, and reliable. And the Buildpacks API defines the contract that any Buildpacks should implement. Interestingly, the cloud-native Buildpacks project itself does not provide any Buildpacks, because Buildpacks are developed and maintained by the community, primarily led by Paketo. Paketo open source, it's an open source project that provides production-ready Buildpacks for the most popular languages and frameworks. It's not the only one, but it's the principal one. Finally, the stack. So a stack consists of two main components, a build image and a run image. The build image provides the base image from which the build environment is constructed, whereas the run image provides the base image from which the application image is built. Okay. But what is the real value of having this stack and having all this layer? Well, let's think about how many images we have in our registry. Maybe hundreds, thousands, I don't know. What if a critical vulnerability is identified at the OS level, at the OS layer, and we have to update hundreds of images? Well, sometimes you are unlucky, and and you need to patch all your images that you discover that are individually managed and are all different. This is the worst scenario, obviously. So it can require months, maybe. But even if you are good enough and your Docker file have a common model, the time you have to spend to mitigate can be, in every case, too long, because you have to rebuild, retest, and redeploy all your images. How can it work with Buildpacks? Well, the main key point is that is the layered model. Because we have an application layer, we have a build-pack layer, and a NOS layer, and they are stored in different repositories. And then we have a manifest that references all these layers. So when we have to change one of these layers, it's just a matter of creating a new layer and change the reference. What does it mean? It means that we can deploy multiple new images in seconds or minutes. So what are the key takeaways about what we have seen today? Well, software security requires a holistic approach. Of course, Cloud Native Buildpacks doesn't solve all our security aspect, but Cloud Native Buildpacks can help simplify and automate some aspect of your software supply chain. Then the Cloud Native Buildpacks project is a widely adopted standard that allows you to have greater modularity, faster builds, reproducible image builds, and finally, more security for your software supply chain. Yeah, here I reported some resources to investigate further, and my contacts. So, thanks.
Thank you, Chiara. Time for some questions. I have one. You said many times that security is important. It has to be built in your work pipeline, but you know, people are always pushing for developing and run, break things, and do stuff. In your opinion, other than obviously using Buildpacks, do you have any suggestion what is a good balance between the security need and the agility of the developer?
Okay, thanks for your question. Yes, as I mentioned, our approach to security must be a holistic one, must be a globally one. No one can avoid think about security if you are a developer or an operation. So there is no more differences in this approach. And yes, even as I said, even the supply chain is now one of the main source of attack. So it's important to choose tools and approaches that are simple, that are reproducible, and that are automated, because complexity is growing, and we can't complicate even further our daily job.
Okay.
Thank you.
Thank you.
Thank you.